All right, so we are on lesson 27, problem 1 of the first page of problems. Jenny had 45 milliliters of a 2 molar sodium hydroxide solution. If she mixed all 45 milliliters of the solution with hydrogen chloride, how many grams of sodium chloride could she produce from this reaction? Water is a byproduct of the reaction. Now, this has a lot of steps, but we'll just do them one by one, and hopefully this will all make sense. Okay, so the first thing you do is you write the equation. Okay, sodium hydroxide plus HCl yields sodium chloride plus water. Okay, then you balance it. Fortunately, this one's already balanced. If you want to double check, that would be fine. Just pause the video and count all of the components. Okay, so, but we're going to go with this is balanced. Next step is underline the components that we're looking at. So we are looking at sodium hydroxide and sodium chloride. Now this is a good time to do some calculations now that you know the two components that you're working with. One is a mole to mole ratio, which is 1 to 1. Okay, and then also calculate the formula weight for the sodium hydroxide and the sodium chloride, because those, you will need those formula weights because you're given grams, or you're asked for grams. So what I do is I actually just calculated all that and put it up in the corner here. Yours will be a little smaller, but mole to mole ratio is 1 to 1. Molar mass of the given product is sodium hydroxide, that's 40 grams. Molar mass of the unknown, what we're trying to calculate for, sodium chloride is 58 grams. Okay, so we're going to go back to where we were. Okay, the next step is expanding molarity to moles per liter. So we're given 2 molar sodium hydroxide, which is the same as 2 moles of sodium hydroxide in 1 liter. Okay, so we are going to calculate the mass for the given molarity. So we take our 2 moles of sodium hydroxide per 1 liter and multiply that by the formula weight of sodium hydroxide, which we just calculated is 40 grams. 40 grams of sodium hydroxide, the moles cancel, and then you have 80 grams of sodium hydroxide in 1 liter. Okay, but we were only given 45 liters. So this is the next step. We're going to set up a ratio. So if there are 80 grams of sodium hydroxide in 1 liter, or you can convert that to 1,000 milliliters since we were given milliliters, then how many grams, that's equal to how many grams in 45 milliliters. Now you can cross multiply and then do some more dividing, but this one's pretty easy. All you need to do is multiply both sides by 45 milliliters, and then the 45 milliliters cancels on this side, so you have just X, and then you multiply all this, your milliliters cancel, so that you end up with just grams. And you do all those, you punch all those in your calculator or do them the old-fashioned way, and you get 3.6 grams of sodium hydroxide. Okay, so then what do we do with this? Well, we can convert it to moles, or we need to convert it to moles. So we convert grams to moles, and this is the beginning. This is how many moles. We're trying to figure out how many moles we started with. Okay, so then to convert grams to moles, you take your 3.6 grams of sodium hydroxide, multiply it by your formula weight, and you get 0.09 moles of sodium hydroxide. Okay, now we're going to apply the mole ratio. Mole ratio is 1 mole of sodium chloride to 1 mole of sodium hydroxide. We want to put mole of sodium hydroxide in the denominator so they cancel, and you end up with 0.09 moles of sodium chloride. Okay, then our last step is converting moles to grams. So we take our 0.09 moles of sodium chloride and multiply it by 58 grams of sodium chloride over 1 mole, so our molar mass that we calculated earlier, and we end up with the answer of 5.22 grams of sodium chloride. I should have put sodium chloride there, but hope that helps. We'll do number 2 in a bit.